Good morning, Professor Sun and TAs. Today, I will talk about heart failure prediction using natural language processing of electronic health records. Electronic health records are designed to store data accurately and to capture the state of patient across time. So it's more effective to extract medical data for the examination of possible trends and long-term change in a patient. And it's really easy to share and store the data. So the data set we use for this study is MIMIC-3. It's taken from over 40,000 patients who stayed in the ICU of the Beth Israel Deaconess Medical Center from the year 2001 to 2012. We labeled patients who were diagnosed with heart failure according to the ICD-9 code in the electronic health record. So here's a list of all the ICD-9 code associated with any kind of heart failure. So broadly, we go through 4 steps in the experiment. First is data preparation, which is done in PostgreSQL. The second is structured processing in Spark and Scala. And third is natural language processing. And fourth is predicting the model. So in the first step, we found about 30% of the patients are with heart failure. And in total, there are about 73,000 notes on heart failure patients. And in total, there are nearly 300,000 notes. And we divide that into 70% training set and 30% testing set. So we go through 5 steps in the text mining. First, we split the text into tokens and eliminating the white space and any non-alphabetic characters from the clinical note. And we remove the words less than 3 characters. Second is removing the English words that do not contribute to a specific meaning under this analysis. So 101 tokens were removed. And for each text, a vector of the term frequency is built. And fourth step is scale the vectors in order to downweight the frequently occurring terms. The last step is clustering applied to the text mining results in order to reduce dimension of the data set for classification algorithm. So in total, there are 500 clusters were created. So the prediction, we use 4 algorithms. First is gradient boosted trees. Second is logistic regression. Third is feed-forward neural network. Fourth is random forest. From the results, we see the gradient boosted trees have the highest prediction accuracy. Only using the clinical notes, we achieve about 81% accuracy. And we only use the structured data, there are 78% accuracy. And when you combine these 2 sources, it's 81.2% accuracy. We also draw the ROC curve on these 4 methods. We can see that by combination of clinical nodes and structured data, the gradient boosted tree has the best performance and the largest area under the ROC curve. About the training time, the gradient boosted trees has a relatively short training time compared to the high prediction accuracy. For future plans, more natural language processing functions can be applied, such as n-grams to access combinations of words and entity recognition to extract more relevant text. Besides, deep learning techniques can be leveraged on top of newer techniques, such as word embeddings. Further development modeling pipelines to allow more parameter tuning is also possible. And finally, we can add more steps to perform variable selection before classification. Thank you for listening.